This here is a virus. Really? How can a PDF file be a virus? It's not like an Excel file. At first glance, that might be true, but in 2021, this was exactly the case. If you own an iPhone and used iMessage, you're as good as hacked. Anyone could be a victim, even politicians, which would have dramatic consequences. Due to the vulnerability called ForcedEntry, it was possible to send infected PDF files to random people via iMessage and hack their phone, without them even interacting with the file. A so-called zero-click exploit. Once the PDF file arrived, iMessage created a simple preview of the file using the JPEG-2 parser, where compressed images were unpacked. And that is where the vulnerability lies. JPEG-2. The hackers built their own small computer inside iMessage and were thus able to infiltrate the entire iPhone, the so-called weird machine. When the PDF files were processed, compressed images were also unpacked. This involved the JPEG-2 decoder being called by an iOS subsystem. JPEG-2 creates a square memory area where the image is stored as a bitmap. A bitmap is a matrix of color values represented by numbers like 0, 1 or 132. These can be interpreted as bits, which are then just 0 or 1. This is the basic puzzle piece for a functional computer. The biggest problem, however, is the availability of bit-level logical operations such as AND or XOR or shift, which could be applied to the memory fields to build complex circuits. For example, the first row of the memory field can be compared with the second row using the XOR command to see if the bit pairs differ. This memory field has the dimensions of an image file. A standard Full HD image is 1920 by 1080 pixels, so this field is 1920 by 1080 bits in size. Then follows the final step on the way to gaining full access to the device. The weird machine is able to create data structures in Objective-C within the bitmap. Just like images, these objects are simply a sequence of numbers. More precisely, it was an NX expression. This is a class from Apple's standard library used to interact with other objects in the process and call their functions. For example, like this one here. With this simple string, you can determine the length of the string. It allowed access to all objects and functions that were available in the process. After the JPEG-2 parser finishes its work, all objects remaining in memory, including the objects in the bitmap, are deleted and the memory is freed. Normally, the operating system uses a so-called yellow command, which simply releases the memory. Because the object was artificially created at the bit level and not via the operating system itself as usual, the object was simply executed instead of being deleted. In this way, the hackers managed to escape the sandbox. In the case of ForcedEntry, it wasn't just the length of the string being determined, but the NSXPC framework being used. NSXPC is a part of the Objective-C standard library. Using NSXPC, it was possible to call Objective-C objects in entirely different processes, even over the internet. This is exactly what the hackers did. A binary file was downloaded from the internet, decrypted, and interpreted as a data structure by Objective-C. The content of this file was executed as program code. Full system access was granted. Apple reacted immediately after the hack was announced. In September 2021, for all apps, the use of NS expressions was completely banned. According to Project Zero, a Google research team that studied the design of this malware, the hackers wrote about 70,000 command chains consisting out of AND or XOR and shift commands to create the weird machine and then an NX expression that allowed full access to the device. This hack was one of the most complex exploits in history. See you next time.